All right, so these two sections are put together. It's confidence intervals for difference between proportions and difference between two means. Okay, so the last couple sections for confidence intervals, we had mean and proportion, but now what if we're doing two different samples and figuring out what are the differences between them? Okay, that's basically what we're doing. So in other words, we're literally just going to subtract either the means or proportions, and the good thing is it's basically the same concept. Obviously, the margin of error is going to be a little different, but just like the last chapter, it's roughly the same. Okay, so first off, when it comes to difference proportions, this is going to be our new parameter. We're going to subtract the P1s, the P2s when it comes to it. And same thing applies for the means. We're just going to subtract both means, and that's going to be our actual, if you want, like our total X bar itself. Okay? So same process as the last one when it comes to our point estimates of our parameters. It's going to be, again, the subtraction minus the margin of error. This is going to be in the middle because that's actually the difference. Again, that's subtraction plus C. So it's the same concept as we did last time, right? It's P hat minus C, P in the middle, and P hat plus C, right? Same exact concept, except now the P is just going to be the subtraction, and the P hat is the difference of those itself. Same thing applies over here for X bar, right? So this was X bar minus E, mu, and X bar plus E. Same concept again, because we're doing differences, we're subtracting them accordingly. Okay. So again, right, the only difference between these ones is basically how to find margin of error. And notice finding the margin of error for proportion, this is for proportion, looks pretty ugly, right, when it comes to it. Autofocus here. Okay. Yeah, pretty ugly, right? The mean one doesn't look too bad, but still looks pretty horrible when it comes to it, right? But since we're online, what I'm going to give you guys a break is I'm going to give you guys each of these itself. Okay, so what that means is you don't actually have to calculate it by hand. I will provide it for you in the question itself. Okay, and this is really bad here. Autofocus maybe be better. So maybe we'll keep the autofocus this time when it comes to it. Okay. All right. So the one thing you do have to know is the DF, right? To find our, so you're going to have to pretty much know everything besides that. So you have to calculate everything accordingly. So for the difference of means, our degrees of freedom is going to be the smaller of the two sample sizes minus 1. Okay. Which means when it comes to our means, you're going to have two different sample sizes, and the smallest one, minus 1, is your degrees of freedom itself. Okay? So let's just go to an example so you can see how this is going to be applied in our case here. So question 1 says, in a survey, 80% of men were asked if they prefer computer-assisted instruction to lecture, kind of like we're doing today, right? Based, and 73% of women preferred computer-assisted instruction for lecture-based. So, they're doing men and women. So there are 100 men, 100 women surveyed in a study. Construct a 95% confidence interval for the difference of the two proportions, given E is equal to 0.117. Okay, so essentially how this is going to work out, right? Since I'm giving you the margin of error, you're still going to write down, everything we actually need itself. Okay, so step 1, we want to find our margin of error, which is pretty much given to us. Right. Step 2, we want to find the confidence interval. So since we're doing proportion, it's going to be exactly that. So you still have to do the work and subtract the actual proportions. So, in this case, P1 is 0.8 because that's corresponding to the men, and P2 is going to be corresponding to the women, so 0.73. Okay. So in this case, it's going to be 0.8 minus 0.7 minus our margin of error, where it's P1 minus P2, and the same thing on this side. And now we just simplify accordingly, right? Just plug this in a calculator itself. Okay. So on the left side, it's going to be negative 0.047. And on the right side, just the addition of it. And there's our confidence interval. And there we go. Okay. And then lastly, we write our conclusion, or not a conclusion, but our interpretation, right? So we are 95% confident that the difference of the population proportion of men and women that prefer computer assisted lecture is between, and there are two numbers, right? Negative 0.047 and 0.187. Or if you want to go in percentages, this doesn't really make sense, right? But, you know, it's still technically portion. So negative 4.7% up to 18.7%, if you want it that way. Okay. That's pretty much how this is going to go by, right? So a little easier than the other ones because you actually don't have to calculate margin of error. Okay. So that's for proportion. So how is a mean going to look like here? Okay. So question 2 says, in a random sample of 30 people playing slot machine, the mean age was 50.7 years with a standard deviation of 5.8 years. In a second sample of 39 people playing roulette, the mean age was 59.3 years, a standard deviation of 2.2 years. Find the 99% confidence interval for the difference of the two means of gamblers. Okay, now if you're wondering what's going to be, 1 and 2, how it's always going to look like is your x1 is always going to be the first thing given to us. So in this case, x1 is always going to be people who are doing slot machines. So that means it's going to be 50.7. And therefore x2 is the people who are doing gamblers, because the second option given to us, or sorry, roulette, in this case is be 59.3 years. Okay. And that's how we label those accordingly there, right? So step 1, we're given E to be 3.038. Step 2, find a confidence interval, and it's something the same thing, right? We're still going to subtract the means, so it's going to be 50.7 minus 59.3 minus our mean. Have our mu1 minus our mu2, and then the same thing, but now we're just adding our margin of error. Again, at this point, we're just plugging the calculator. Okay, so the differences are between negative 11 to negative 5. So, right, that means there's, this would make sense because on average, there were older people on the roulette table itself. Okay. And there we go.